Hello, now we're going to talk about the equality of complex numbers in polar form. So if you have two complex numbers, if they are equal, two things need to happen, right, to be equal. First, their argument, or their not their argument, their modulus needs to be the same, or their magnitudes need to be the same. But our arguments, or angles between them, it should be, they should subtract, and it'll be equal to 2 pi k. If this doesn't quite make sense, think about, a complex number, right? Trying to draw this a little bit better. Let's see, a complex number in the complex plane, right? If you have some complex number, let's say z right here, right? Well, for that angle to be the same, you could wrap around, 360 degrees, or 2 pi, right, and be the complex number, but it could wrap around 3 different times. Who knows how many times, right? So basically, we want these angles, right, if we say theta 1 equal to theta 2, but it could end up being that theta 2 could be, another 2k pi around, and we end up with the same complex number, regardless of the angle that goes around. So 2 pi k, the way I read it up there. And then I can subtract these. You can see that theta 1 minus theta 2, if they are the same vector, the same complex number that wraps around to that same position and ends up landing right here, is equal to 2 pi k, right? So we can use this concept to find out if complex numbers are actually equal. So an example they give us is this guy, example 2. It says find all possible r and theta such that, we know that these complex numbers z and 1 have to be equal. If these parameters are true, we know that the modulus of complex number z1 is r squared, and its argument is 3 times theta. And then for the z2, its modulus is 5r minus 6, and its argument is theta plus pi. So let's start with the first one. We know these are equal. So its modulus is going to end up being r squared is equal to 5r minus 6. And I can solve this equation subtracting everything to the other side. I get minus 5r plus 6 equals 0. This factors nicely for us. And I get r and r. This is minus, and 3 and 2. So my r can be either a 2 or a 3 to make this true. So I know in this situation our modulus has to be either 2 or 3. Those are two possible answers. Now the other one is I can use the formula that we talked about up here. If we can subtract them, if we subtract their arguments, their angles, it has to come out to 2k pi, or 2 pi k, right? So I know 3 theta minus theta plus pi has to become 2k pi, right? And then this would be 3 theta minus theta, that would be 2 theta, right? And then this would minus theta added, so I got 2k pi plus pi, right? And then divide by 2. My possible answers are k times pi plus pi over 2, right? After I divide, right? So if I wanted to come up with possible answers, I could say k equals 0, and it would be a plus or minus pi over 2, right? Whether I plus or minus pi over 2, plus k equals 1, and it's going to be plus or minus 3 pi over 2, right? And then if I do k equals 2, that would be 5 pi over 3 plus or minus 5 pi over, not pi over 3, pi over 2. And this continues infinitely. We could keep wrapping it around. And these are the conditions for which the complex numbers z sub 1 is equal to z sub 2. And there you go, guys. Thanks.